Hello, quick video of the MEI syllabus and questions they do on functions and their inverses. Here's a classic sort of question, not particularly long, from June 2010. So as ever, first thing we do is read the question. The function is defined by, there we go, f of x equals that function of x. And then behind it, after our comma here, we've got this. Inequality for x, that's our domain, yeah? So that's our input, domain, input. Think of ID, if you can't remember which way round, ID, to get a drink in this country, so you need your ID, input is the domain. Okay, what they're asking us to do, they're saying given that this function has an inverse, there we go, standard form of notation for it, find the inverse and its domain. Okay, so I'm sure a lot of you have done this in the past. So here's our function, and of course quite often we rewrite that as y equals 1 plus 2 sine of 3x. Yeah, we replace the fx with the y. And then to find the inverse, we're going to swap over our two variables. So we just write it again as x equals 1 plus 2 sine of 3y. And then we just need to rearrange the equation to make y the subject. So our first step of that will be to write x minus 1 equals 2 sine of 3y. That's our first step. And then we're going to divide by 2. Every function, we're just undoing them here. Every operation, aren't we? So now we've got x minus 1 all over 2 equals sine of 3y. I'm going to change sides here, swap sides, because I want to end up with y on the right-hand side, left-hand side rather. There we go. So sine 3y equals x minus 1 over 2. And what do we do next? Well, we're going to find our inverse of sine, which is arc sine. Here we go, arc sine. You know, what we in our calculators at GCSE is actually sine minus 1 using the inverse function sort of notation. So there we are, and our final step is to write y equals 1/3 of the arc sine of x minus 1 over 2. So there's a classic sort of first part to the question, and we've done that. So what was the second part it asked us to do? Was to find, we need to find the domain, of f minus 1x. Well, the best way to do this is to think about our input function and our domain of that, and our range, the output of our original function, and then reverse the process. So let's just quickly draw out what we had here. So we started off with an input domain for our function. It was our function f of x. So the input domain, they told us in the question, was between minus pi over 6 and plus pi over 6, wasn't it? That was the inequality they wrote for us. Okay, and that's going to give us our output here, our output range. And we can calculate that in a sec. That's what we're going to do. And then if we want to go the other way, we're going to have our inverse function. So I haven't written that clearly enough. F minus 1 of x. And we're going to go that way, aren't we? And in this point, for our domain, for our inverse function, is going to be, our domain here, for our inverse function is going to be the range of our original function, isn't it? The output range of our original function. So let's work that out, shall we? Okay, I'm going to do this in blue so we can see it. So on our input range, where we've got when x equals minus pi over 6, then f of x was going to be 1 plus the sine of 3 times minus pi over 6, which is 1 plus the sine of minus pi over 2. Well, the sine of minus pi over 2 is, sorry, I missed my 2's out again here, haven't I? The sine of minus pi over 2 is going to be, excuse me, it's going to be minus 1, isn't it? Therefore, our value here is going to be minus 1. Happy with that? And then our upper value, at this point looks like an upper value, but we have to watch out that the transformation doesn't switch them. So let's just put these in. When x is pi over 6, then f of x is 1 plus 2 times the sine of 3 times pi over 6, which equals 1 plus 2 times the sine of, well, the bracket's now pi over 2, and the sine of pi over 2 is 1, isn't it? So we've got 1 plus 2 times 1, and that lot equals 3. So therefore, our output range here, output range of f of x is, our f of x is going to be greater than or equal to 1 and less than or equal to, sorry, minus 1 and less than or equal to 3. Okay, and therefore, if we're now looking at our inverse function, therefore, for our inverse function, f of minus 1 over x, this is going to therefore be the input range, the input side domain. So the input will be equal to the input domain of that function, and therefore our input domain is between minus 1 and 3, and again it's greater than or equal to. So there we are, that's our second section of that, and I suspect, let's just check, just checking, so we get 2 marks for finding this inverse range here, so that's worth 2 marks here. So input domain, and we get 4 marks for doing the original function. So there we go, up here. Here, there's 4 marks for that. 4 marks for finding the function, 2 marks for the input domain of the inverse function. Okay, so a very quick summary here. Key learning points. So we've got our input domain for our function here, and that gives us our output range. And if we reverse the function going the opposite direction, then now our input range for our inverse, our input domain for our inverse is the output range of our original function, and the output range of our inverse is the input domain for the original function. So if you think about it, it's just entirely circular here, isn't it? And in order to find the inverse function, we're going to write it in the form y equals fx. Then we swap the variables, so we have x equals f of y, and then we rearrange the function, so at the end of it we have y as the subject, so therefore y will equal f minus 1 of x. There we go. Have fun.